Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at some more commands that can be used to perform tasks on disk files. Today we're going to look at a few more commands you will find useful when operating on disk files. The first command we're going to be looking at is file scan. This command allows you to scan quickly through a file to work out, first of all, how many records exist in the file and what the widest string within the file actually is. In order to use the file scan command, we will first need a file, so we will create one of these first. We'll create a generic routine that can be used to create a file and populate it with some random data. Since we're going to be using random data, the first thing we need to do is to seed the random number generator. We can do this by using the randomize command, which takes a single parameter, which is the seed for the random number generator. If we use the timer, every time we run the application, we should get a different set of random numbers. We're going to create a test file into which we're going to put this random data. We're going to populate the path to and the name of that file in our start data variable. We will then call our new routine to create a file on disk. So before we go any further, we will create this new function to create a file. Our new function is going to take two parameters. Firstly, the path and the name of the file, and the second being the number of rows of data we wish to create within that file. We're using the freefile command to get the next available file handle. We're opening the file name for output as that file handle. And then we're going to print to this file a number of rows. And all we're printing into the file is a random number between 1 and 1000. And if that is successful, we're returning true as a return from the function. I'm trapping the command for opening the file in a try-catch block, just in case there are any problems with creating our file. So if we try running the application as it stands now, all it will do is to create our new file. And there it is, testfile.txt. And it contains no less than 300 rows, and each row has in it a random number between 1 and 1000. Now that we've created this file, we can try a file scan on it. So we know from our command we've created 300 rows in this file. Let's see if file scan returns the same number. So I'm going to embed a new function called run file scan. This will be embedded in the call to our log. So the output from run file scan will be a string because that's what funlog is expecting. So we're passing to our new function a single parameter, which is the path and the name of the file that we wish to scan. So there is that single parameter being passed to the function. And now we want to try and open the file. So as we've done many times before, we will pick up the next available file handle. And we're going to embed the open command for opening the file in a try-catch block. So we're opening the file for input using our file handle. And then comes the file scan command. Once your file has been opened, you can use file scan followed by the file handle and the words records to. And this will generate a value within the row count variable of the number of records it finds within the file. This is on the assumption that our file is a Windows file with a carriage return line feed at the end of each row. So this single line of code can be used to return exactly the number of rows within our file. We can go further and have the optional part of this command, which is width. This will tell us the width in characters of the widest string. So if we have a file with 300 rows in it, it will return the width of the row which is the greatest in size. So since the function is going to return a string, we can populate that string with anything we need. So in this case, we are taking the word file, we're adding on the tail end of our path, which is actually just the name of the file. We're using the slash as a delimiter, and we're using it with -1, which means we're taking the last element of that string, which in this case will be the file name. and we're saying how many rows we've discovered within our file scan, and we're also saying what the widest string is, how many characters. And should we attempt this on a file that does not exist, we can use the catch statement to pick up that error. And in this case, we will populate the result variable with the words "an error occurred," and error $ will have in it whatever error actually happened. And our last part in this function is to populate the return of the function. So if we run our code now, we will see it's returning to say that the file testfile.txt has 300 rows, and the widest string is 5 characters. This command can be very useful to determine the number of records within a file before you start processing it. So now that we've scanned a file for the number of records within it, what else can we do on the file? Having created a file, we can use PowerBasic to effectively rename the file. The file at the moment is called testfile.txt. If within our code we wish to amend the name, it can be done quite easily. We'll set up a new variable to contain the name of the new file, which in this case is going to be new testfile.txt. And we're going to use the name command within PowerBasic to change the name of the file. And we will again embed this in a try-catch block. The name command takes only 2 values: the name of the file you wish to rename and the name that you wish to rename it to. We've added on the path, so we're explicitly saying where the file actually exists and what the file's name is. So if we do a compile on that, and we attempt to run the application now. Below this is our testfile.txt. If we run the application, it says it has been renamed successfully. And if we look, we'll see that the file is now called new testfile.txt. If we attempted to run that application again, you'll see it's been unable to rename the file because the file already exists. So this is your error message coming out on screen. The original file is still there, and the old file is still there. To avoid this problem, we're going to attempt to delete the new file name before we try to rename the old one. Again, we will use a try-catch block, and we'll use the kill command to attempt to erase any evidence of the new test file. If we compile our code now, and attempt to run it, we'll see the file is now renamed successfully. Another feature of the name command is the ability not only to rename the file, but to change the directory in which the file exists. In order to prove this, we're going to use the make directory command within our PowerBasic application to create a new directory, a new subfolder. And we'll also use the isFalse/isFolder command to test to see if that directory already exists before we attempt to create it. This will allow our application to be rerunnable. So we're using the isFolder command, and we're testing to see if it's false. And we're giving it as a parameter the path of the executable and the folder name data. So if that folder does not exist, it will then attempt to use the make directory command to create the folder. So if we recompile this, and we attempt to run our application now, we will see that the data folder has now been created. At the moment it's empty, but we're going to use the name command to first of all create a file called testfile. It will then rename the file new testfile and position it within the data folder. This will not just be copying the file, this will effectively be moving the file. So when we get to this point in the code, there will be a file in the root of the executable path called new testfile.txt, and we want to move that file inside the data new testfile folder. So this isn't renaming the file, this is just moving it. So as we did before, we're going to use a try-catch block to attempt to erase a file of that name in that folder. So now we're going to use the name command again with its 2 parameters, the start file, which is the new testfile.txt, and the new file, which is the same file name but in the data folder. And again, should this error, we will be getting a message back out to the log saying we're unable to move the file. So let's just compile that now. And if we look back in our folder, we'll see that the data folder at the moment has nothing in it. If we run the application now, it will tell us that the test file has been created. It has been renamed to new testfile.txt, and it's telling us it has been moved successfully. We will see that our new testfile.txt does no longer exist within the root of the folder, but in the data folder it does exist. So we've effectively used the name command to move the file from one directory to another. We can also use that command to move and rename the file by simply setting the value in new file to be something other than the file name in the source. So if we run the application now, it will tell us it's been renamed and moved successfully. So we'll see in our new folder we have a new testfile.txt. The original file we copied previously is still in there. So let's clean both of these out and run the application again just to prove that it's working properly. And there in our data folder is new testfile.2. So the name command can be used for two things. It can be used to simply rename a file in a directory. And secondly, it can be used to move a file into another directory and optionally rename it at the same time. This for things like log files can be very useful indeed. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.